Okay, so this is lesson 5, unit 1A, horizontal transformations and transformations combined. Okay, so we're going to first look at horizontal reflections. In the top right corner over here, you'll see a negative x value within the brackets. This indicates a horizontal transformation, and this indicates that there is a horizontal reflection on the y-axis. So if you draw your function in your graph, it would reflect like this along the y-axis. And this only applies to the x value, which is negative, which has to be negative. And that's all you need to know for horizontal reflections. Okay, so moving along, horizontal stretches. There's two parts to that. There's horizontal compression, which makes your function narrower, and horizontal expansion, which makes your function wider. Two things that you need to remember for that is that horizontal translations are opposite to what they seem, and you have to remember to factor out the coefficient of x. So I have an example here that will help you understand this a little bit more. So looking at the k value, which indicates a horizontal stretch in your function, the k value here is 3. So since it's within the bracket, you would do the reciprocal of that, because you would do the opposite, because the horizontal translations are opposite. So opposite of that is 1 over 3. That would mean that the function is actually compressed. Vice versa, if the k value was 1 over 3, you would do the reciprocal of that, which would be 3 over 1. And so that means the k value is 3 and it would be stretched. See that? So that's all you need to know for horizontal reflections and horizontal stretches. Just remember to factor the coefficient, and that horizontal translations are always opposite to what they seem. Okay, so looking at this second part, we're looking at combining transformations. There are 4 parts here, 4 values here, and they each indicate different things. The a value indicates vertical stretch compression, and if it's negative, then it reflects off the x-axis. The k value indicates horizontal stretch compression, and if it's negative, it reflects off the y-axis. D value indicates a horizontal translation along the x-axis, so it's a shift up or down. And you would do the opposite to what it is. So if it's a negative 2 here, then you would shift 2 to the right, 2 units to the right. And then for your last value here, C, it's a vertical translation, so it's a shift up and down along the y-axis. Okay, so these are your 2 key points, quadratic functions and root functions, and you would take these a values, you would apply to the x and the y values to find your graphing points. So k and d would be your x values, and a and c would be your y values. Okay, that's all you need to know for that. We're going to move on to the question. So for the first question, we have describe the transformations made. Okay, so this is the function y equals f bracket 2x plus 8 minus 4. So now looking at this, I could see that there's a coefficient in front of the x, and so we need to factor that out. And so when I factor that out, I would get y equals f bracket 2 bracket x plus 4, where I factor the 2, bracket minus 4. So this would be my factored form, and now I can describe the transformations made. So I'm going to look at my x values first. So looking at my k value, it's a 2. Knowing that it's within the bracket, I would have to do the reciprocal. I have to look at the reciprocal of that, which would be 1 over 2. That means that there is a horizontal compression of 1 over 2, by a factor of 1 over 2. Okay? And then I'm going to look at my next value, which is x, but there's no negative in front of it, so knowing that there's no negative, I know that there is no horizontal reflection along the x-axis, so I can just leave that alone. If I move on to my next value, I'm looking at my d value, which is a horizontal shift on the x-axis, and since it's a positive 4, I would do the opposite to it because it's in the brackets, so I would move it left 4 units. Okay, so we're done with the x values. I'm going to move to my c value, which is outside the bracket, so I'll leave it the same. And since this is a shift vertical, I would move this negative 4, so down 4 units, which is what I wrote there. So now I'm going to look at my f value. Now there's no a value in front of the f, and I know that if there's no negative, that means there's no vertical shift along the x-axis. So this is all the transformations I made. Horizontal compression by a factor of 1 over 2, horizontal shift by 4 units, vertical shift 4 units down. And that's all there is to it. Hope you understood.